Okay, the next part of the question asks for us to find the interquartile range. So to find the interquartile range, I'm going to first need to be able to find the upper quartile and the lower quartile, and I'm going to start with their position formulae. Okay, firstly, how many pieces of information am I working with? And there are 31. All right, the question didn't actually tell us how many there were going to be, so it was on us to be able to count, basically. Do yourself a favor and check that twice to make sure you have the right value there. So how do I find those quartiles? Q1, its position is going to be n plus 1 divided by 4, and Q3 for the upper quartile is going to be 3 times n plus 1 divided by 4. Okay, so where am I going to find them? So substituting in that 31 plus 1 over 4, 32 over 4 equals the 8th piece of data. I can track that down. And since this is going to be 3 times n plus 1 over 4, that is simply going to be 3 times 8, the 24th piece of data. Okay, the interquartile range. Okay, so let's pick out those pieces of data. So the 8th is going to be the 1, is going to be this value right here, and the 24th piece of data is going to be this value here. The interquartile range we're going to find by Q3 minus Q1. Okay, the difference between upper quartile and the lower quartile. Okay, so the interquartile range is Q3 minus Q1. What are the actual values of Q3 and Q1? Well, let's be extremely careful. Referring back to the key, says that actually this would represent a temperature of 16. So I'm actually adding 1 to the stem, or I'm adding the leaf to the stem to know exactly which number I'm talking about. For the upper quartile, this is going to be 25 plus 2. So the value there is actually going to be 27. And for the lower quartile, it's 15 plus 1, which is going to be 16. Okay, so working this out, 27 minus 16 leaves us with 11. The interquartile range was 11. Okay, using that, can we determine whether 3 is actually an outlier? So as I said before, when we looked at the shape of the distribution, whether or not we decided 3 to be an outlier should have a bearing on what type of distribution we were going to use. But let's leave that to the side for now. Is 3 an outlier? We can find outlier boundaries by doing one of two things. An outlier boundary will be found by taking the upper quartile and adding on 1.5 multiplied by your interquartile range. Anything above this would be considered an outlier, or by taking the lower quartile and subtracting 1.5 times the interquartile range. Anything below this will be considered an outlier. Since 3 is the smallest value, we should be using the second version to try and evaluate whether or not 3 counts as an outlier. Lower quartile, 16. Interquartile range of 11. Working this through, 1.5 times 11 is 16.5. So 16 minus 16.5 equals negative 0.5. Anything below negative 0.5 will be an outlier. 3 is not below negative 0.5, so it can't be counted as an outlier. Let's finish off with a statement here. 3 is greater than negative 0.5, so it is not an outlier. And that will be worth all your marks.